Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Hakimi bin Mahmud with Geometric P0920100081. I am from BMMP2543/1 and I am from Group 3, which is presenting about shaping. So I am tasked to present about the deformation method, which is I will mention about extrusion and rolling process. Okay, so for the bulk deformation process, it divided by two, which is extrusion and rolling process. So for the extrusion is the process of squeezing toothpaste from its tube in one of the extrusion. The gooey toothpaste of the gooey polymer or metal in the industrial process is forced by pressure to flow through a shaped die, taking up the profile of the die orifice. In co-extrusion, two materials are extruded at the same time and bond together, a trick used in toothpaste to create a color strip in it. So for the rolling process, in rolling, a metal ingot is squeezed to shape by massive roll that subject it to a large plastic deformation. Nearly 90% of the steel product are rolled and forged. Billet and sheet are made by the plain rolling. I-beam and others such as continuous section are made by shape rolling. In hot rolling, the ingot heat to about 2/3 of its melting temperature. It falls through a series of rolls that progressively shape the profile. Okay, as you can see, this is the process of the extrusion and rolling process being done. This is a cinematic diagram. As you can see, for the extrusion, there is a direct extrusion and indirect extrusion. So for the direct extrusion, as you can see, this die is inside the cage and the ram is giving the pressure into the billet and result the extruded product as you can see right here. So for the indirect extrusion, die is put outside the billet. You can see it's indirect for the billet. Then the ram is pushing and it's also result the extruded product as you can see right here. Okay, so for the rolling process, you just put the hot metal, as you can see right here, in the between the roll to this roll. Okay, and then the hot metal will come through and bring the shape, give you the shape like this. Okay, uh, the profile that you want for the process. Okay, so this will explain the detail about the process. Okay, so for the extrusion process, it supports the circular prismatic, non-circular prismatic, and physical attribute masses. Mass range is about 1 to 1 exponent 3 kg, and range of the section thickness is 1 to 900 mm. Tolerance is about 0.5 to 1 mm, and roughness is about 0.8 to 3.2 micron, and surface roughness is B. Okay, so for the process characteristic, primary shaping process support the process, primary shaping process, and the continuous process. And then economic attribute, relative tooling cost is actually high, relative equipment cost also high, and labor intensity is low. So for the rolling process, it support the circular prismatic and non-circular prismatic. Physical attributes, mass range is about 0.1 to 2 exponent 3 kg. Range of section thickness is 2 into 250 mm. Tolerance is 0.1 to 0.5 mm. Roughness is about 3.2 to 12.5 micron. And surface roughness is about B. So process characteristic, prismatic shaping process is also support and is a continuous process. And economic attribute, relative tooling cost is actually high, relative equipment cost also high, and labor intensity is low. And then economic batch size is the unit is about 100 to 1 exponent 4. Okay, so that's all from me. Thank you so much.
Assalamualaikum, my name is Muhammad Ahmad Fahmi bin Armi. My number matrix is B0920102442. Now I'm going to talk about thermoset molding. There is two types in this thermoset molding. For the first one is injection molding and the second one is resin casting. Okay, for the first one is injection molding. There is no other process has changed product design more than injection molding. Injection mold products appear in every sector of product design, such as consumer products, business industrial, computers, communication, sports equipment, and others. The most common equipment for molding thermoplastics is the reciprocating screw machine. As we can see in this diagram, polymer granule Polymer granules are fed into a spiral press where they mix channel into the die. The polymer solidifies under pressure and component is then injected. Okay, next we move to resin casting. Many resins are sufficiently fluid polymerization that can be cast. In the resin casting, a mix of resin, hardener, and catalyst is poured into a shape mold without applying pressure. If the part is small, the mold can be made of an elastomer, allowing complex cast shapes to be removed without having a split mold. A few thermoplastics, like notably acrylics and the most thermosets, can be cast. For the characteristic part, first, injection molding. It can be shaped for circular prismatic, non-circular prismatic, solid 3D, and hollow 3D. For the physical attributes, mass range is 0.001 until 25 kg, range of section thickness 0.4 until 6.3 mm, tolerance 0.07 until 1 mm, roughness 0.2 until 1.6 micrometer, and for surface roughness is smooth. Next, process characteristics. It can be used for primary shaping process and discrete. And for the economy attributes, relative tooling cost is very high. For the relative equipment cost is high. Labor intensity low, and economic batch size units 1 exponent 4 until 1 exponent 6. For the resin casting, it it's also can be shaped for circular prismatic, non-circular prismatic, solid 3D, and hollow 3D. For its physical attributes, for its mass range 0.1 until 700 kg, range of section thickness 6.25 until 600 mm, tolerance 0.8 until 2 mm, for roughness 0.5 until 1.6 micrometer, and for the surface roughness is smooth. Next, for the process characteristic, this resin casting also can be shaped to primary shaping process and discrete. And the last one is economic attributes. For the relative tooling cost is low, relative equipment cost is low, labor intensity is medium, and for the economic batch size is 1 until 500 only. That's all for me. Thank you.
My name is Muhammad Iqbal bin Zawrin. My matric number is B0920102114. Okay, right now I will explain about blow molding. Blow molding is glass blowing technology adapted to polymers. Hot air is forced under pressure through the membrane, blowing the polymer against the mold walls where it cools and freezes. In stretch blow molding, an important variant, the temperature is chosen such that the polymer is drawn as it expands, orienting the molecules in the plane of the surface. Okay, right now we move to characteristics. It have three shapes. The first one is flat shape, second D-shaped shape, and the third is hollow 3D. For physical attributes, mass the first one is mass range 0.005 until 0.3 kg. Range of section thickness 0.4 until 3 mm, tolerance 0.25 until 1 mm, roughness 0.2 until 1.6 micrometer. Surface roughness is calculated by area. Process characteristics have two. The first one primary shaping processes and then discrete. For economic attributes, relative tooling cost is medium, relative equipment cost is also medium, labor intensity is low, and economic best size unit is 500 until 57. From the process schematic, as we see the picture have a mold and the material. So the air will enter from the blank area, and then the mold will close, and then the hot air will enter the mold from material and make it shape it and inside the mold. Next, injection molding. No other process has changed product design more than injection molding. The most common equipment for molding thermoplastics is the reciprocating screw machine. Polymer granules are fed into a spiral press where they mix and soften to a dough-like consistency that can be forced through one or more channels into the die. Polymer granules are heated and forced by the screw through a nozzle into the die. Okay, and after then, after that is characteristics. For the shape, it has four shapes: circular prismatic, non-circular prismatic, solid 3D, and hollow 3D. For physical attributes, mass range 0.001 until 25 kg. Range of section thickness 0.4 until 6.3 mm. Tolerance 0.07 until 1 mm. Roughness 0.2 until 1.6 micrometer. Surface roughness is area. And process characteristics have also two: primary shaping processes and discrete, and the economic attributes different from blowing mold. For the first one is relative tooling cost very high, relative equipment cost is high, but labor intensity is low. The economic best size 1:4 until 1:6. From the process schematic, as we know, as we see, the material will enter from the granular polymer, and the machine will heat the material until the material melt, and then the screw will push the material into the mold and make the molding injection molding process begin. Okay, that's all from me. Thank you.
Good morning. My name is Taniswaran. Today I would like to talk about powder methods, specifically powder pressing processes. There are two powder pressing processes. First, hot isostatic pressing. There are few trade names for this process, which is HIP, cap processes, or Seracon processes. In hot isostatic pressing, a powder is sealed in a deformable metal container and then subjected to a high temperature at high pressure, which is 1100 Celsius and 200 megapascal, in a can pressure vessel, inside which there is a furnace surrounding the container in which the process is loaded. Argon is used as a pressurizing medium. In the sinter heat process, a variation of heaping, the initial sintering of the compacts and their subsequent densification are done sequentially in the same vessel. The main advantage of this process is its ability to produce components which are 100% dense and having uniform isotropic properties, but it is expensive, limiting its use to those applications in which the integrity of the material is of the prime importance. For example, turbine discs and blades. This is the process schematic, and the next slide will be for the characteristic of the process. Okay, next we're gonna see pressing and sintering, which is one of the process of powder pressing. Powder methods have particular value in shaping difficult materials such as ceramics and refractory metals. For instance, they are too brittle to deform and have high melting temperatures, so cannot be easily cast. In powder pressing and sintering, the loose powder is packed in a shape mold of steel, graphite or ceramic, in which it is sintered at a temperature typically of 2/3 of melting temperature of the powder. In pressing and sintering, the powder is first compressed in a cold die, giving it just sufficient strength to be handled, allowing it to be sintered as a freestanding body. Better densification, strength, ductility are given by hot pressing, which combines compaction and sintering into one operation. The powder is heated in a graphite or ceramic die under sufficient pressure to compact the powder to nearly full density. The process is mainly used for components that are too large for regular cold pressing and sintering. Its use is limited by the cost of dies, the difficulty in heating and atmospheric control, and the length of time required for a cycle. Vacuum hot pressing is used for powders that are particularly sensitive to contamination by oxygen or nitrogen. For example, titanium. This is the process schematic for the process, and the next slide will be characteristic of this process. Thank you. That's all from me.
Good day everyone, my name is Pavindran Chettiar, son of Kadrivel Chettiar from class BMMP, and my metric number will be B0920100392. So for today, I would like to explain about sand casting. This slide consists of introduction, types of sand casting, process schematic and characteristic. So first of all, I would like to start with introduction. Sand casting is a process where a mixture of sand and clay is compacted in the split model around a pattern that has the shape of the desired casting. The pattern is removed to leave the cavity in which the melt metal is poured. Wooden patterns and aluminium patterns are used to derive shape of the cavity. Generally, there are two types of sand casting. First would be evaporative pattern sand casting, and the second will be low pressure sand casting. For process schematic, there are 6 stages of the process. First, place the flat-sided half pattern and compact the pattern with the mixture of sand and clay. The second step would be place the other half of the pattern which is already compacted with the mixtures. Third, using the sprue pin, create pouring basin so that it will be easy to pour the melted metal. Finally, remove the pattern and clamp back the two-sided adrex. Finally, before pouring the metal, create vents above the mold. So for characteristic, there are few factors need to be considered. First would be shape, physical attributes, process characteristics, economic attributes, and cost modeling. This information is derived from the CES EduPack software. So this will be the characteristic for evaporative pattern sand casting, which also consists of shape, physical attributes, process characteristics, economic attributes, and cost modeling. And the last part would be the characteristics of low pressure sand casting, which also consists of shape, physical attributes, process characteristics, economic attributes, and cost modeling. So that's all from me. Thank you.
Greetings to my respective lecturer and to my fellow friends. My name is Murali Analeki Muniandi and I'm from class 3 BMMP. My metric card number is B0920100306. Today I would like to talk about the shaping process, which is the die casting process. Next, in this presentation, I would like to explain about the introduction of the die casting process, the types of the die casting process, the process schematic of the die casting, and also the characteristic of the die casting. First of all, the introduction to the die casting. The die casting is a manufacturing process in which molten metal is poured or forced into the steel molds. Generally, it produces dimensionally accurate precision metal parts with a high quality finish. Then its ability is to produce detailed parts make it perfect for the mass production of the products. The process of die casting is very efficient, economical that offers a broad range of shapes and components. The parts produced usually have a long life and can be produced to be visually appealing, giving designers significant advantages and also the benefits. Next, in the die casting process, there is three types of die casting process, which is the first one is gravity die casting, the second one is high pressure die casting, and the third one is low pressure die casting. Now, let's take a look on process schematic of the die casting. The first one is gravity die casting. The gravity die casting process schematic is pouring a molten metal into the pre-milled casting dies under gravity force. The molten metal fill into the casting dies naturally and then get the desired casting parts. This process called gravity die casting. And then the second one, high pressure die casting. The process schematic for the high pressure die casting is, in this process, a metal die having a cavity with the negative geometry of the part is created. The die is mounted onto a machine capable of injecting molten metal at high velocities. Then, the die cavity is closed. Molten metal is poured into the short sleeves. The sleeve opening is closed and a ram moves forward to force the metal into the die while generating high levels of applied pressure. Then the third one, low pressure die casting. The process schematic for the low pressure die casting is the process begins with a melting furnace which melts the metal alloys and brings them to the casting temperature. For the example, aluminum has a casting temperature of 710 to 720 Celsius. The molten metal will then go to a holding furnace below the mold, which functions as a container while maintaining the liquid at the casting temperature. The low pressure forces the molten metal through a riser tube into the mold. The liquid metal moves under constant pressure until the molten metal solidifies in the die cavity. On solidification, the pressure is released and the remaining molten metal goes back through the riser tube to the holding furnace for recycling. Finally, the casting will be easily removed once the mold is cooled. Last but not least, let's take a look on the characteristic of the die casting. The first one is gravity die casting consists the shape, physical attributes, process characteristic, economic attributes and also the cost modeling. For the second one, high pressure die casting also consists shape, physical attributes, process characteristic, economic attributes and also cost modeling. Then the third one, low pressure die casting. The characteristic of the low pressure die casting also consists the shape, physical attributes, process characteristic, economic attributes and also cost modeling. From this we can know that the three types of die casting consist almost the same characteristic. These results are taken from the CES EduPack application. Lastly, that's all from me for the presentation of the die casting. Thank you.